Salutations I bid to my fellow friends and my comrades fighting for justice. Today, I'm going to introduce you in a very interesting and an astonishing topic, which is introductions to organic chemistry. So before we kickstart this lesson, my name is Muhammad Aishafi bin Ahmad Mubaki, or you can call me Ice. I'm in practicum D1, D10, and I'm currently studying in College Multiplication in New Zealand. So, before we start, we need to know what is structural formula. So, structural formula is a chemical formula that shows how the chemical bonds are bonded to each other in the molecule. Thus, structural formula can be drawn in three structural formulas, which are condensed, expanded, skeletal structure, which I'm going to explain in my next tutorial. So, first, expanded structure shows all the covalent bonds between them and does not represent the actual shapes of the molecule. So, there is an example here. Ethanoic acid, C2H4O2. C, carbon, is electronegative and hydrogen is electropositive. So, these are covalent bonds. Okay? So, you show all the single bonds and double bonds. So, this COOH, the classification of compound is carboxylic acid. But as you can see, if this is a functional group, this is carboxyl. Okay? Because it consists of double bond oxygen plus with OH. Okay. Next, another example I gave. Butanol. Butanol, they have C4H9OH. There are 4 carbons and 1 hydroxyl. So just unpack this, which means expanded structure. When you see ethanoic acid, you know C2H4O2. You need to expand in order to see that you can identify the functional group and you can identify the classification of compound of the molecule. Okay, next, condensed structure does not show single bonds between carbon and hydrogen atoms, but double or triple bonds are shown. Next, all atoms which attach to a particular are written immediately after the carbon. So, an example here, ethyl acetate, C4H8O2. So, we can see here, the functional group here is carboalkoxy, and the classification of compound is ester. So, the terms is, you have double bond oxygen, followed by an oxygen in the middle attached with another 2 carbons beside. So we call it as carboalkoxy. This is the functional group. Okay. So how do you want to draw into a condensed structure? So since I said based on this molecule, you know that it is C4H8O2. You want to expand it first. That is the first step. You expand it and you can identify. So first C carbon attached with 3 hydrogen. Next, another carbon attached with double bond oxygen. Another oxygen. CH2CH3. Okay? So, in this expanded, we want to try and compress it. That's why it is called condensed. We want to make it more simplified. So, in a more simplified way, this 1 carbon attached with 3 hydrogen, so we write it as CH3 COOC. You can write it as COOC, like this. Okay. I'm wondering that some of you would ask me why we don't show double bond in here. Well, double bond and triple bond occurs between carbon atoms. It doesn't occur between carbon and oxygen. So you don't have to show, unless it is because carbon and carbon show double bonds. So when carbon attached with double bond with oxygen, you don't have to show. Okay, that is to indicate that is the functional group of the molecule. Okay, so moving on, we have skeletal structure. Skeletal structure is the bonds are represented as lines. Carbon atoms assumed to be at the beginning and at the end of the line where 2 lines meet. Thus, does not show carbon and hydrogen atoms, but functional groups and atoms other than carbon and hydrogen must be shown. So, there is an example here I gave. Butane is C4H10, right? It is a saturated hydrocarbon. So we have 4 carbons and 10 hydrogens. We line up as this. This is the simple example that I gave first. Okay. When you draw skeletal structure, you need to know one line consists of 2 carbon. Okay. Like I said, bonds are represented as lines. So it's when in like this form, we change into lines. So 1 carbon. Next, all the edges, we name it as carbon. Okay. So how do you want to know whether it's correct? 1 carbon, 2 carbon, 3 carbon, 4 carbon. So there are total 4 carbons. But how you want to put the hydrogen? Okay. Same thing. Hydrogen, you can put here 3. Edges, you put 2 maximum, and at the end and the beginning of the carbon, you should put hydrogen 3 because maximum you can put 3 hydrogens. Okay. Next, another example I think is butanoic acid, C4H8O2. Okay, this is the expanded structure for butanoic acid. The functional group here is carboxyl. The classification of compound is carboxylic acid. So here we have hydroxyl and the double bond oxygen here. Okay, so this is the expanded structure, and now I'm going to convert it into skeletal structure. So how do we do it? Okay, so first 1 carbon, 2 carbon, so draw 1 line, the other line, another, and another. Okay, so total count the number of carbon first. 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay, so there are 4 carbon. Okay, so how do you want to put OH and double bond oxygen? Okay, so this carbon here at the end, drop another line to indicate that is the another compound other than carbon and hydrogen. See, does not show carbon and hydrogen atoms, but functional groups and atoms other than carbon and hydrogen must be shown. So this is not carbon or hydrogen, so you need to state clearly. So OH you put at the end, and double bond you put upward like this. So this is the skeletal structure. And that, ladies and gentlemen, I have concluded that most of you would be able to draw structural formula in the form of expanded, condensed, and skeletal structure. Okay, moving on, we're going to talk about classification of carbon atoms. So, it is quite simple and not too difficult. It depends on the number of other carbon atoms bonded directly to the carbon. So, this is just a general knowledge. Okay, so first, here are the definitions. We need to know 4 things. Primary carbon, the carbon is bonded directly to one other carbon. Secondary carbon is the carbon is bonded directly to 2 other carbon. Tertiary carbon, the carbon is bonded directly to 3 other carbon. Quaternary carbon is the carbon is bonded directly to 4 other carbon. And ladies and gentlemen, please take note. When you want to classify carbon atoms, you need to always remember this only happens in saturated carbons only, not unsaturated. Okay? Alright, so and one example that I'm going to give you, ladies and gentlemen. Okay, we have an expanded structure here. Okay, so how do you want to classify the carbon atoms? First, we look at the definitions first. How do you want to identify primary carbon? So primary carbon is bonded directly to one other carbon. So 1 carbon directly to one other carbon. So it is primary carbon. See? 1, here also 2, 3, 4, 5. Okay, this is condensed structure, ladies and gentlemen. You can either draw in expanded form or you can draw it as condensed, but make sure all of this you have to change into condensed. Okay, this is just for you guys to see. Okay, next, if you want to look at secondary carbon, it must be bonded directly to 2 other carbon. So that means there are 3 carbons you need to remember. So 1 carbon attached to another carbon, which you call it as secondary carbon. 1 here and another one is here. Okay, next. Okay, so based on this expanded structure, if we want to identify that tertiary carbon, the carbon is bonded directly to 3 other carbons. So you need to take note 4 carbons here. How? 1 carbon attached to another 3 carbon, so we consider this as tertiary carbon. Next, last but not least, we want to identify quaternary carbon. So from this structure, there is 1 carbon attached to another carbon. We call it as quaternary carbon. So the carbon is bonded directly to 4 other carbons. So you have to take note, here we need to have 5 carbons in order for that to happen. Alright, so if that question asks you how many carbon atoms present in this molecule, so you list it out, how many primary carbons, secondary, tertiary, quaternary. So total there are 5 primary, 1, 2, 3, 4, 5. Next, secondary, we have 1, 2, so there are 2 secondary carbons. Tertiary we have 1. Quaternary only have 1 carbon atom. So total there are 9 carbons in this molecule. If you want to recheck the answer is correct or no, look here. 9 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9. So total there are 9 carbons here. So that indicates that your answer is correct. And with that, ladies and gentlemen, we have reached this end of this video, and I would like to thank you all for spending your quality time with me by watching this video, and I hope you get the knowledge and information that you needed in future. And with that, I apologize if there's any wrongdoings, my mistaken in words, language. Truly sorry. And with that, I want to help you all to understand more better in introductions to organic chemistry in future later. And with that, I thank you very much, and please subscribe to my video and give it a big thumbs up. Thank you very much. I see you all next video.